There is a direct proportion between two variables when one variable is a simple product of another. So let's say petrol in litres is directly proportional to its cost. So we could, let's say, write litres is directly proportional to, let's say, X as money. So to replace this reverse fish symbol into something that's equals would be L equals KX. K is the constant. So for example, let's say I spend £75 on 60 litres of petrol. If we plug this in here, you're going to get 60 equals K 75. If we now rearrange this, K is going to equal 0.8. We take this K value and we plug it back in here. So you can get L equals 0.8x. We now have a general formula for calculating the amount of money spent on petrol with this relationship, when this price and this ratio between each other is the same. So let's say I want to know, I put in 80 litres into here. So into my car, you're going to have 80 litres equals 0.8x. If I rearrange this, 80 over 0.8 equals £100. So I've spent £100 to get 80 litres. So this is how you find out when something is directly proportional. The key is to find out what K is, the constant, creating this general formula, and then usually in questions they'll give you loads of other variables or other scenarios that you're in. You plug them in and you can find out what the value is. Inversely proportional is when there are two variables and one variable is directly proportional to the reciprocal of the other. So let's say I have y is directly proportional to 1 over x. What we did in the previous example with direct proportionality, we can replace this with equals k. So you're going to get y equals k 1 over x, or y equals k over x. So this is our general thing for whenever you're finding out inversely proportional relationships between things. These variables might be different, they might be p, q, s, t, whatever, but it's always going to be something equals k over something else. So a good example of it is, let's say, the speed in which you're going and arriving somewhere and the time it takes to arrive. The faster you go, the quicker you're going to arrive. The slower you go, the longer it's going to take you to arrive. So let's say I'm going 50 kilometers per hour and it's going to take me 2 hours to arrive. We can plug that in here. So let's say y is the speed I'm going. So I'll switch it out to s equals k over t. That's going to be 50 equals k over 2. Therefore, k multiply both sides by 2 equals 100. So now we plug that back in here. You're going to get s equals 100 over t. So we've now found out what the general formula is for the inversely proportional relationship between speed and travel. So let's say I was going 200 kilometers per hour. You get 200 equals 100 over t. If we rearrange this, t, I'll multiply both sides by t and then divide both sides by 200, is going to be 100 over 200, which is 0.5 hours. So it's take me half an hour to reach my destination if I quadruple the speed in which I'm driving at, which makes sense because it's taking 4 times longer, 0.5 to 2, if I'm going a quarter of the speed. Direct and inverse proportionality.